Today, we're diving into one of the most powerful techniques in natural language processing, named entity recognition, or NER. Have you ever wondered how search engines understand what you're looking for, or how chatbots instantly know whether you're talking about Apple, the company, or Apple, the fruit? That's NER in action. By the end of this video, you'll understand what NER is, how it works, and how you can start using it in your own projects. So let's get started. So what exactly is named entity recognition? NER is a natural language processing technique that identifies and classifies named entities in unstructured text. Think of it as a smart highlighter that automatically finds and categorizes important information. It recognizes things like people, for example, Elon Musk, organizations like Tesla or NASA, locations such as New York or Mount Everest, and dates and times like September 2024 or 3 p.m. Basically, NER transforms messy, unstructured text into organized, structured data that computers can easily process and analyze. Now let's look at the different types of entities that NER can detect. First, we have person entities. These are names of people, both real and fictional. For example, Marie Curie, Sherlock Holmes. Next, organization entities. Companies, agencies, institutions. Think Google, the United Nations, Harvard University. Then location, or GPE, which stands for geopolitical entity. These include cities, countries, and landmarks like Paris, Japan, or the Eiffel Tower. Date and time entities capture temporal expressions, anything from yesterday to December 25th, 2024 to next Monday. We also have money, monetary values like $100, 50 euros, or 1,000 rupees. And product entities for products and services, iPhone 15, Tesla Model S, Windows 11. These are just the basic categories. Depending on your domain, you can have specialized entities like gene names in biomedical text or chemical compounds in scientific papers. All right, so how does NER actually work under the hood? NER typically follows a 4-step process. Step 1, tokenization. The text is split into individual words or tokens. Apple CEO Tim Cook becomes Apple CEO Tim Cook. Step 2, feature extraction. The system analyzes each token and its context. It looks at things like capitalization, surrounding words, part of speech tags, and word shapes. Step 3, classification. Based on these features, the model assigns entity labels. Is Apple a company? Is Tim Cook a person? Step 4, post-processing. Finally, the system refines and validates the results, resolving any conflicts or ambiguities. Now, there are 3 main approaches to building NER systems. Rule-based NER uses handcrafted rules and dictionaries. For example, if a word starts with capital letters and is followed by ink, it's probably an organization. Simple but limited. Machine learning NER uses algorithms like conditional random fields or support vector machines trained on labeled data with linguistic features. And deep learning NER, the current state of the art, uses neural networks like BiLSTM, CRF, or transformer models like BERT and GPT. These models learn complex patterns from massive amounts of data. Let's see NER in action with a real example. Here's our input text. Apple Inc. CEO Tim Cook announced the new iPhone 15 in Cupertino on September 12, 2023, with prices starting at $799. Watch what happens when we run this through an NER system. Apple Inc. gets tagged as an organization. Tim Cook is identified as a person. iPhone 15 is a product. Cupertino is a location. September 12, 2023 is a date. and $799 is money. Just like that, we've extracted all the structured information from a simple sentence. This is incredibly powerful for data extraction and analysis. Now let's get our hands dirty with some code. I'll show you how easy it is to perform NER using spaCy, one of the most popular NLP libraries. First, we import spaCy. Then we load a pre-trained English model. Core WebSM is a small but efficient model perfect for getting started. We define our text. Apple Inc. was founded by Steve Jobs in Cupertino. We process the text through the NLP pipeline with NLP text. This returns a doc object that contains all the linguistic annotations. Finally, we loop through doc.ents, all the entities found, and print each entity's text, its label, and a human-readable explanation. And here's our output. Apple Inc. is tagged as ORG for organization, Steve Jobs is a person, and Cupertino is identified as GPE, a geopolitical entity. That's literally all the code you need, 5 lines to extract entities from text. How cool is that? So, where is NER actually used in the real world? The applications are endless. Let's start with document parsing and knowledge extraction. Organizations process thousands of documents daily: contracts, invoices, legal agreements. NER automatically extracts key information like parties involved, dates, amounts, and terms. This saves countless hours of manual data entry. In finance, NER is a game changer. Here's a news article. Tesla stock surged 5.2% after CEO Elon Musk announced record deliveries in Q4 2023. Analysts at Goldman Sachs upgraded their price target to $350. NER extracts Tesla and Goldman Sachs as organizations, Elon Musk as a person, Q4 2023 as a date, and $350 as a monetary value. Financial institutions use this for sentiment analysis, tracking how often companies are mentioned and in what context, for risk assessment, identifying entities involved in financial events, for portfolio management, automatically extracting company names for investment tracking, and for compliance, detecting suspicious entities in transaction records. In journalism and media monitoring, NER automatically tags articles with relevant entities. This helps organize content, track trending topics, and monitor how often specific people, companies, or locations appear in the news. News agencies use NER to create knowledge graphs, connecting related stories and entities. Healthcare is another major application. Here's a clinical note. Patient John Smith presented with chest pain. Prescribed aspirin 100 milligrams, follow-up scheduled at Mayo Clinic on March 15, 2024. Medical NER doesn't just extract general entities, it identifies domain-specific ones. John Smith is the patient. Chest pain is a symptom. Aspirin 100 milligrams is a medication. Mayo Clinic is the healthcare provider. And March 15, 2024 is the follow-up date. This helps in automating medical records, extracting clinical information for research, and supporting clinical decision-making. In e-commerce and marketing, NER helps with product categorization, brand detection, and understanding customer feedback. Companies analyze reviews to extract product names, brands, and features customers are talking about. This provides valuable insights for product development and marketing strategies. For customer support, NER automatically routes tickets based on detected entities. If a customer mentions a product name or account number, the system can intelligently assign the ticket to the right team or even provide automated responses. Now, NER is powerful, but it's not without its challenges. Let's look at both sides. On the benefit side, NER automates information extraction at massive scale, processing millions of documents in minutes. It improves search and retrieval accuracy. Search engines understand what you're really looking for. It enables structured data from unstructured text, turning paragraphs into databases. It dramatically reduces manual annotation time. And it powers downstream NLP tasks like question answering and text summarization. But there are challenges too. Ambiguity is a big one. The word apple could be a company, a fruit, or even a person's nickname.
Context is everything. Domain-specific entities need specialized training. Medical NER models won't work well on legal documents. Multilingual and cross-lingual scenarios are tricky. Models trained on English don't automatically work for Hindi or Chinese. Context-dependent entity boundaries can be confusing. Is it New York, or New York City, or New York University? And finally, good NER requires quality labeled data, which can be expensive and time-consuming to create.
So you want to build your own NER system? Let's talk tools. spaCy is my personal favorite. It's a Python library that's production-ready, fast, and comes with pre-trained models, perfect for most use cases. Stanford NER is a Java library popular in academic research, using CRF-based models. Hugging Face Transformers gives you access to state-of-the-art models like BERT, Roberta, and GPT for NER. Incredible performance. NLTK is great for educational purposes and basic NER, though not as powerful as the others. Flare offers cutting-edge contextual embeddings for NER. And if you want managed services, AWS Comprehend provides scalable NER as a cloud API. Let me show you another code example, this time using Hugging Face Transformers. We import the pipeline function. We create an NER pipeline using the BERT-based NER model with simple aggregation strategy. This groups multi-word entities together. Our text is, Microsoft was founded by Bill Gates and Paul Allen in Seattle. We run the pipeline and get our results. Look at these confidence scores. Microsoft is detected as OR with 99% confidence. Bill Gates and Paul Allen are both person entities with 99% confidence. And Seattle is a location with 99% confidence. These transformer models are incredibly accurate because they understand context deeply. What if you need to detect custom entities specific to your domain? You'll need to train your own model. Here's the process. First, collect data. Gather a corpus of text from your domain. Second, annotate. Label entities using tools like Labelbox, Prodigy, or Docano. Third, prepare data. Convert to training format using IOB or BILO tagging schemes. Fourth, select a model architecture, CRF, BILSTM CRF, or fine-tune a BERT model. Fifth, train. Fine-tune on your label data with proper validation. Sixth, evaluate. Measure performance using precision, recall, and F1 score. Finally, deploy. Integrate into your production pipeline. Let me quickly show you what IOB tagging looks like. This is how we format training data for NER models. Each token gets a tag. B- means begin, the first token of an entity. I- means inside, a continuation of the entity. And O means outside, not part of any entity. So Apple gets B-ORG because it's the beginning of an organization. Inc. gets I-ORG because it's inside that same organization. CEO gets O because it's not an entity. Tim gets B-PER as the beginning of a person's name, and Cook gets I-PER as the continuation of that name. This tagging scheme helps the model learn entity boundaries precisely. How do we know if our NER model is good? We use 3 key metrics. Precision answers of all the entities we identified, how many are actually correct? Formula, true positives, divided by true positives plus false positives. Recall answers of all the actual entities in the text, how many did we find? Formula, true positives, divided by true positives plus false negatives. F1 score is the harmonic mean of precision and recall. It gives us a single number to evaluate overall performance. For instance, a model with 95% precision means very few false positives. It rarely calls something an entity when it's not. 88% recall means it missed some entities. There's room for improvement. The F1 score of 91% shows overall strong performance. Before we wrap up, let me mention some advanced techniques taking NER to the next level. Transfer learning, using pre-trained BERT or Roberta models and fine-tuning on specific domains dramatically improves accuracy with less data. Active learning,
Selecting the most informative samples for annotation reduces labeling effort by up to 70%. Multitask learning, training NER jointly with related tasks like part of speech tagging, improves performance through shared representations. Few-shot learning, recognizing new entity types with just a handful of examples using meta-learning techniques. Ensemble methods, combining predictions from multiple models, improves robustness. And zero-shot NER, using large language models to identify entities without any training data, just through clever prompting. Here's a complete production-ready NER pipeline class you can use. We create an NER pipeline class that loads a spaCy model, has an extract entities method that processes text and organizes entities by type into a dictionary structure. Simple, clean, and production-ready. So what's next for NER? The future is incredibly exciting. LLM-powered NER models like GPT-4 and Claude are enabling zero-shot and few-shot NER with simple prompts, no training needed. Multilingual models, universal NER models working across 100+ languages without retraining. Entity linking, not just finding entities, but connecting them to knowledge bases like Wikipedia and Wikidata for richer understanding. Real-time processing, models optimized on edge devices for instant entity extraction. Fine-grained entities, moving beyond basic categories to highly specific types like gene names, chemical compounds, and product SKUs. Continual learning, models that adapt to new entities without forgetting previous knowledge. All right, let's wrap up with the key takeaways. Number 1, NER is essential. It's a core NLP technique that transforms unstructured text into structured data. Number 2, powerful tools are available. spaCy, transformers, and cloud APIs make NER accessible to everyone, from beginners to enterprises. Number 3, wide applications, from healthcare to finance, journalism to e-commerce. NER powers intelligent applications across every industry. Number 4, the field is evolving rapidly. Transformer models and large language models are pushing the boundaries of what's possible. The bottom line is, you can start building with NER today. The tools are mature, the models are powerful, and the applications are limitless. And that's a wrap on named entity recognition. I hope you found this deep dive valuable. If you enjoyed this video, please give it a thumbs up and subscribe for more NLP content. I've got tutorials on transformers, sentiment analysis, and much more coming up. Drop a comment below and let me know. What will you build with NER? I'd love to hear your ideas. Thanks so much for watching, and I'll see you in the next video. Happy coding!